Good afternoon, everyone. This is Michael Malik here with the Hurricane Outlook and discussion for November 22nd, 2020, recorded around 4 p.m. Eastern Time. Taking a wide look across the tropical Atlantic this afternoon, not much going on, really and truly not much going on. We have an area of disturbed weather out here across the central Atlantic, and this will be skirting kind of towards the north and east over the next several days. Could bring an increased rainfall threat to portions of Bermuda during the next several days, but not really expecting any tropical development out of this at all. The Hurricane Center currently gives this area a 20% chance of development over the next several days. Again, generally skirting off towards the north and east here with time and passing close enough to Bermuda to bring some rain, maybe some gusty winds from time to time. But other than that, this should be quietly moving on out into the tropical Atlantic and not really causing much of a concern down the road from there. In the Indian Ocean and Arabian Sea, we have a severe tropical cyclone Gadi, I think that's how you say it, or Gadi. Sustained winds were roughly at about 115 miles per hour before landfall there in Somalia. The storm has now crossed over and is significantly weakening. Still expected to be a tropical storm, and again, tropical storm watches and warnings do exist for some of those areas, and you can refer to the earlier update I made here on this tropical cyclone. This will be rapidly moving inland and weakening, and again, may pop out for a brief second there in the Gulf of Aden, and then just kind of pop back in over Ethiopia, kind of doing this weird curvature. So, not really expecting much more out of it, but certainly some heavy rainfall and gusty winds will exist as the primary threat for the next several days or so. But other than that, not really watching anything else. Now, as we turn our attention towards the lower 48 weather, that was kind of the end of the hurricane outlook and discussion. There's not really a lot more to cover, so we're going to be gradually focusing on now the lower 48 weather and severe weather prospects over the next several weeks or so. First and foremost, right now across the lower 48 weather, you can see this is the Gfs Simulated Precipitation. We do have a front that is, or a front that is developing out across the north, and we have a fairly good shot of cold air being driven in by an area of high pressure well towards the north here. So this ridge of high pressure well towards the north here off the screen is helping to bring in some of this cool, cool air, some freezing temperatures across portions of northern Illinois, off back in towards the midwestern states. And then we have our cyclone right here, which again, or our little area of mid-latitude cyclonic vorticity. And this is weakly associated with the front. Now you can see what will happen is this will actually join up here in Montreal and Quebec here in the lower parts of Canada and combine to actually form an area of low pressure. And this could bring some heavier rainfall to portions of the Northeast, all the way from the Carolinas through the Northeast. We could see a bit of heavy rainfall, and if we actually go back and look here at the sounding, we'll pop the sounding here closer to New York City. We can see that the temperatures here are 45 degrees here with a dew point of 38 Fahrenheit, it does appear. And again, we can see that if we kind of step forward with time here, this is our forecast 12, we really start to see this moisture field increase. And what's going to be happening is as this mid-latitude energy draws closer, we're going to be getting a surface flow that is going to be largely out of the south. So it's going to start to pump in tropical air. It's going to try to pump in the tropical air mass. So you're going to see kind of a convergence along this area, and actually there is a weak front that is going to be associated in here. It's not very strong. It's a rather weak front, but you can kind of see that as you get closer towards the front here, if you look here at the isobars and the thickness lines between each isobar and thickness line, there is certainly that gradient in there. There's a gradient, but these little boxes in here indicate that there's going to be some fairly steep thermal advection of that moisture from the Atlantic over into the Northeast. So this is going to cause a lot of rainfall to those areas. You could easily pick up, anywhere from isolated amounts could be upwards of 3 inches or so, maybe even more. And again, this is going to cause a long period again of just this onshore flow across portions of Florida. So still looking for some heavier rip currents for that. And then we seem to be setting up next week for what could be a fairly potent situation here. This is by the morning of Wednesday. We'll go back here again. What's going to be happening is we've got a lee cyclogenesis coming off the Colorado Rockies here on the lee side here of the Colorado Rockies. And this is going to help to promote cyclogenesis in a storm generally that takes a more northeasterly trajectory. And you can see out in front of it here, these wind barbs, you've got a ridge of high pressure here over the northeast. And if you kind of just follow the return here, these, isobars, they basically, go out of the south. So you're basically drawing up a lot of moist tropical air. And if we switch back here to the 250 millibar wind here, you can see that in the 250 level, we have this trough that's coming down here. And we've got lee cyclogenesis here, a fairly potent jet stream and jet max. But if you look over the southeast United States, what's going to be happening here, there is a fairly potent area of wind here. And this is actually the subtropical jet. We've got a subtropical jet extending from portions of Mexico through southeastern Texas, then in through the southeastern United States, and then out in across the mid-Atlantic. And then we've got the secondary kind of axis right here associated with the trough and the lee cyclogenesis factor. So these two areas, this could be a prime severe weather factor, and we're actually going to dive into some of the severe weather mechanics right now. So this is the GFS forecast, the 2-meter dew points, and again, this is by Wednesday night, or really Tuesday night going into Wednesday morning. This is by 7 p.m. Tuesday. Again, you can kind of see that we already have that moisture advection across the south here. That strong moisture returns with 60 dew points in southeastern Oklahoma and into Texas, and then we can also see that we have kind of the secondary tongue of moisture being pumped up here. Not very deep moisture, but this little tongue of moisture being kind of slingshotted in towards the Ohio Valley. Now you notice that if we go forward with time here, what you'll actually start to see is that this moisture tongue begins to increase with time here. So this is by Wednesday morning, 1 o'clock. Now you'll start to see here a very distinct front here. This is kind of a cold front that's located right in about here. And you have your warm front roughly located right about there. And you also have an occluded front that's kind of back here. You've got an occluded process with the low that is going to be somewhere back in this general vicinity. So with time here, that's going to really matter because that is going to promote for the storm to really draw up this kind of area, to really draw up a lot of moisture in this environment. Now, if we take a sounding here from the GFS here into portions of central Arkansas, we'll just go with central Arkansas here. This is again for the morning of Wednesday by 2 o'clock or 1 o'clock here in the morning. Now, a couple of things that you'll note here in the sounding. We'll go ahead and zoom in a little bit so you can see better. First of all, looking at the SKU-T here and looking at the thermal charts. So what we've got here is we're definitely not in any contaminated sounding. We don't have ridiculous, theta E values across here. But what you do notice is 64 Fahrenheit surface temperature over 62 Fahrenheit dew point surface temperature. So what that is indicating to me is a very moist, rich tropical air mass, and that kind of just coincides with what we were seeing in the dew point values at that time. Now, if we go forward here, we can kind of see that looking up, we do have somewhat of a lapse rate, but it's not a very steep lapse rate. This is kind of a weak to moderately positive lapse rate. We can tell that because the temperature is kind of decreasing with height. We can see that the temperature does decrease with height. We'll actually try to highlight this in a better color here, but the temperature does decrease with height here, and that is important because this supports the fact here that we have at least somewhat of a weak to moderate lapse rate in this environment. However, you can see down here where we start looking at the instability values. The instability in the surface is only 122, and mid-level cape, mid-level cape is only 349, and most unstable from the most unstable parcel is only 445, and that is actually elevated. So we don't have any surface-based thunderstorms in this environment. Going to be very hard to get tornadoes in this sort of environment. Now, if we look over here at the hodograph, and again, if you're unfamiliar with what a hodograph is, basically, this is the same thing as we're looking at here, basically in this chart, but instead it's plotted on a zero relative scale, zero being right here, and this is kind of the true north, basically. So we've got the storm here in the lowest 0 to 2 kilometers, or really 0 to 3 kilometers. This red line is the wind profile in the first 0 to 3 kilometer layer. We can see that there's good shear. The storm or storm parcel inflow layer would really start around 10 knots at the 0 kilometer range and curves by 1 kilometer to roughly about 40 knots, and again is fairly steep through that point. However, we can notice after that point in time, we start to get more. You can definitely tell that we don't have that really good curvature here. So we do have storm motions that are 241 degrees relative to true north and at 49. Now, this would be a right moving, that takes into account for a right moving supercell. But what this really tells us is that we're going to have fast moving storms. 41 knots or 49 knots roughly equivalates to about 55 miles per hour. So we're going to have a storm motion of about 55 miles per hour, and the storm slinky tells us that the storm vector is going to be towards the north and east here at about 55 miles per hour. Very important, because this really tells us that we're going to have a fast-moving storm environment, and these storms will rapidly start to kind of move out of this tongue of moisture here into less buoyant air. So again, this is mainly all really elevated storms at this point. Now, if we go forward here, this is later in the day. This is 7 a.m. Wednesday. Again, you can see this tongue of moisture begins to expand. Again, we see an extending tongue of moisture here, the secluded front becoming very nicely defined. You could probably have some snow here on the backside if the moisture plume is sufficient. But we can definitely tell that we have moisture rapidly increasing. But you'll notice that way up here where we have slightly better dynamics, the moisture is not there. Moisture needs to be at least about 55 Fahrenheit. And if we actually take a sounding up here, this is in southern Illinois at this point, you can see that the moisture field is 56 Fahrenheit, but only a 58 degree Fahrenheit surface temperature. And we can actually see that the surface temperature does slightly increase with height here, roughly at about 2.5 kilometers. That slight increase is enough to put some capping on the environment. And again, at this point, we would have a surface parcel that is elevated and not surface based. Now, what we can tell from here, though, is there's much stronger shear. The vectors start relative here in the first 0 kilometer layer. We have about 15 knots here, curving rapidly in the first 2 kilometers. But you can definitely see, though, that the shear vector is very nicely curved in the first 0 to 2 kilometers. Then after that, it kind of flattens out. So this would be semi-decent for tornadoes in this sort of environment. You can see that the relative shear values are in the 300s, so they're definitely high. And we have classical veering here in the first 0 to 6 kilometer layers. So we know that we have the support here in the wind profile for supercells and tornadoes. However, again, the temperature and also the moisture and instability is going to be very limited. And for that reason, not really forecasting for tornadoes here, but you could get some dangerous straight line wind here with this type of profile, especially given some of the drier air just above, really in the first about 2 to about 5 kilometer layer, you have some slightly dry air that might be able to mix in some of that with downdraft potential. And accordingly, our downdraft Cape values or D Cape values are nearing 500, which is marginally sufficient for microbursts and downbursts. Now, if we take a sounding back here down in the warm sector, this is where those dew points are a little bit higher. What you'll start to notice here is we do have, again, 67 over 63 here. This is actually if we actually look here, this is going to be really right down there in southwestern Missouri, or not southwestern Mississippi, rather. 68 over 64, and you can see that we do have, again, a little bit more in the way of shear in the first 0 to 5 kilometer layer. But again, the moisture is definitely there, but the instability and temperature values are, the instability certainly is very limited. Only mid-level Cape values in the 200s and most unstable parcel almost 300. Not going to be supportive for intense systems at all. However, that 0 through 3 kilometer shear definitely a lot more curved here back in the warm sector. That 0 to 3 kilometer shear vector very well curved here. The storm motion is 252 degrees relative to true north and 37 knots. So 37 knots roughly equivalates to right around 45 miles per hour. So we'd have a storm vector at 252 knots, or 252 degrees relative to true north at 37 knots, so closer to 45 miles per hour. Again, that would be out of generally the northeast there, but you are not going to get tornadoes in this environment unless if you can get some really low-topped supercells. But again, with this type of profile, you likely won't see storms that are able to ascend very far into the atmosphere. Now, if we go further out in time, this is by Thursday or Wednesday night going into Thursday. This is Wednesday at 8 o'clock, or really 7 o'clock p.m. Eastern Standard Time. Again, taking us down to here closer to Birmingham, Alabama, we can see that we do actually now have a temperature inversion a little bit down here at the surface, and then it resumes kind of a weak positive lapse rate. We do have some fairly good 0 through 3 kilometer shear in here, fairly stout 0 to 3 kilometer shear. But again, we don't have a lot of that classical spread with the instability. So not really going to be seeing much in the way of severe weather down here in terms of fairly high tornado potential. And then we move this down here Thursday. This is by 7 a.m. Thursday that residual moisture hangs around. Sounding for Alabama, again, this one would be maybe a little bit more supportive, but again, a surface parcel is not going to be down here rooted at the surface. Instead, we're going to be looking at some elevated Cape here. So again, really not seeing much in the way of tornado potential out here this week. Again, there could be some marginally severe conditions. If we look here at the GFS forecast here, and this is the surface to 500 millibar bulk shear. Again, we'll just go out here Wednesday by noon, or we'll go Wednesday out here by 12Z. And we can really see that, again, we don't have a lot of bulk shear. You can kind of see right along this trailing edge of the front, we have some shear. But elsewhere here, kind of in the warm sector where we'd want some fairly strong shear, these bulk shear values are only in the 40s to 50s. Not fairly high at all, and definitely not super supportive of intense tornadoes at this time. The NAM, this is the NAM model here, and so this is the North American model. We will kind of go out here, we'll kind of speed things up a little bit. Again, this is much of the same. This is Wednesday by 12Z, so by 7 a.m. Wednesday. Again, taking a sample here in southwestern Arkansas down here in the warm sector, does reveal that, again, you might have a little bit more in the way of instability here in the elevated layer. Really in the mixed layer, you don't really have much, only about 730, so a little bit more, but surface capes are still only closer to 600, although we have fairly stout 0 to 2 kilometer shear. But after that, it really starts to dive out here, and even kind of sampling towards Wednesday afternoon, This is 18Z Wednesday afternoon here, again out in the warm sector. You don't really notice much, not a lot of instability, so the tornado potential certainly seems to be relatively limited out here. And again, just more warm sector sampling, not really going to see much of a tornado potential in this environment, unless if you can get some really low topped storms. And again, the bulk shear remains relatively weak, and actually this starts to weaken out as the main dynamics become occluded out across here and generally generally skirt towards the north and east here. So this is really not going to affect much of a supercellular tornado characteristic down there. All right. So that being said, hope you have a great rest of your afternoon and evening. Of course, I am Michael O'Malley. I'll talk to you guys again some more tomorrow.